Hmm? Okay. So today, let's see what is known as electrolytic conduction. See, in electrolytic conduction, we take a container made of glass or any other insulated substance. Okay. Here you can put two electrodes. This electron can be a rod also, plate also. Let me put a plate. And here you will have electrolytes. It can be molten or is aqueous. So this is the one. Okay. Now, so this is being connected. This is cathode and this is anode. It is not my wish. It is a convention to write the cathode on the right and anode on the left. Okay. So you know why it is by this time you know what is cathode and anode, because if the cations migrated to cations are positively charged. So to electrode to which the cations will migrate, this will be a negative electrode. Okay. And this is anion migrate to the positive. Anyway, when I go a little further, then you'll find Uttam may do something. So what will happen? Here, the cations will migrate. Let me write here now Mn plus, Mn plus, Mn. Okay. And the X minus, suppose here, Xn minus, Xn minus, Xn minus. All right. So, so right now here, when a voltage is applied, across the electrodes, you will not get scared what the voltage is applied means what. Either you connect it to a battery or to an electrical source. See, no flows will occur if there is not a gradient. If it is like this, water will not move. If you make it like this, it will move. So always the difference of gradient has to be. So because of that is called when a voltage is applied across. So this is the electrical gradient. Across the electrodes, dipped into an electrolyte. I will write electrolyte. I will not write electrolytic solution because it can be an aqueous solution and it may not be also. Ions of the electrolyte, these are the ions. Opposite charge electrodes and therefore we find that the electrolytic conductivity, though it is different from the metallic conductivity because it flows through wear, is almost same. Okay, so we are going to take the help of the law that we have already studied in physics. So what should I write now here? We'll write light metallic conductors electrolytic solution also obey Ohm's law. I think all of you know what is called Ohm's law. Hmm? Hello? Ohm's law, you remember?
Yes, sir.
What does it say? The current flowing through a conductor is directly proportional to the potential difference. See, if water falls from a great height, so its velocity or speed will be more than the water that falls from a small height, that you know. So same thing is there with the current also. Okay. All natural thing almost obey the same thing. Only thing that we are not able to understand. What should I write now here? I is proportional to V. So what is I? I is the current in ampere and V is the potential difference in what? In volts. Difference across the conductor. Okay. Now I can write, or I can write what? I is proportional to R to V. That you know, or R is what? The constant of proportionality, where R is the constant of proportionality, known as resistance. What I can write now there, V is equal to I R. Resistance. So what is resistance? Resistance is the obstruction. It measures the obstruction to the flow of the current. See, I don't understand physics. I'm very poor. because I read long time back. I'm 99.9% I forgot. But I have found that physics is a part of life. Okay. Hmm. The only thing is that some typical words are being told and some symbols are being used, some constants are being used. But we always face it in our life. So what we will find? The resistance of any conductor is directly proportional to the length of wave. Okay, so I can write here R is directly proportional to L. And second, inversely proportional to the cross section of C. For that physics is not required here. See, suppose this is your school, you want to reach. If someone stays here and someone stays here, he will find more obstruction because the road is long. The road is long, there will be more friction. You'll have more inconvenience to reach. Person who is nearer, distance is less. For him, obstruction is less. But if the person is nearer and road is very narrow and every now and then it is being jammed with vehicle, and if it is a highway, in this case, this person can move faster because the cross section road is wide, cross section is more, resistance is less. So for that, we don't have to know. We are facing every day while going to school. Okay. So therefore, what I can write? What I can write now? Or I can write R is proportional to L by. Or I have to put a constant. So R is equal to rho L by E. See, if L is equal to 1 centimeter and A is equal to cross section. So unit will be 1 centimeter square. So in that case, R is equal to what? Rho. Okay, I'll write here now. Where R rho is a constant known as resistivity or specific resistance. I'll tell you why you call it specific. Why the word specific is being used. Why? Because you have to, whenever you specific, then you have to put a condition. Suppose you have complained to your miss that some of the students are making fun of me. Miss will tell you, no, 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 don't say like this. Specifically, you tell me the name. Because for one, I cannot punish the whole class. See here. Why equals specific resistance? Because we have put a condition. L is equal to 1 centimeter and A is equal to 1 centimeter square. So in such case, we call it resistivity. We can call it specific resistance. So please remember. Okay. Okay, now, if I want to find the value of rho, what I can write? See, I can write, because we have found R is equal to rho L by A. Or I can write rho is equal to R. Whole thing I'll write now. L by, I'll not change it. Finish it and tell. Write what is called conduct. Resistance, we know. Resistance is obstruction. If resistance is obstruction, then conduct is what? That is, here you do not have any obstruction. So if you do not have any obstruction, then what should I call it? Huh? Suppose you have given a difficult sum, then you have lot of obstruction. Each and every step you have to be careful and you have to check whether you made mistake or not. If the sum you can immediately do it, then what you will say? It is very simple. It does not have any obstruction. Or you can simply say it is easy. So conductance it is the measure of the ease with which current flows. Through a conductor. Okay, it is represented by capital G. Okay, it is the reciprocal of resistance R. Okay, what I can write? Therefore, G is equal to, so R, you know what is R? See here, what is the value of R? We'll write it is rho L by A. See, the unit of resistance is ohm. Its unit is ohm or omega. What will be this unit? Its unit is ohm inverse, or what to write it now? See. You have seen the name of this is a very famous electrical person of physics person deal with electricity, and after his name, electric companies are there. We call it Siemens. Okay, the symbol is capital. Just like resistivity, we'll go for conductivity. It is the inverse of resistivity. It is denoted by, okay, this is not R, huh? This is called kappa. So what we can write? That is kappa is equal to 1 upon rho. So but we know rho is equal to what? R L by B. So I can write therefore kappa is equal to 1 R L by B. Or I can write 1 upon R into L by B. Okay. So what is this? This is not conductance. Huh? So we know conductance G is equal to 1 upon R. So therefore K is equal to G into L by, or K is equal to G into G star, where L by A is called G star is equal to called cell constant. We are going to apply now this one in. See, this is the thing that we got it from the metallic conduction. Let us apply this theory on electrolytic conduction. Electrolytic conduction, the conductors are liquid. Metallic conductors are solid. Okay. So conductivity of an electrolytic solution. or specific conductivity. Don't get scared. In whenever you say resistivity, it is L by A. When you say specific resistance, L is equal to 1 centimeter and A is equal to 1 centimeter square. So when we say specific conductivity, here also we are going to put the same term. Okay, so you need not faint. Only thing, you excuse me for your my horrible drawing. I think that only I can rectify in my next bar. See no condition. I'll make it a little small. Okay, so this is the cathode. Cathode means negative, and this is okay. Now see here. This it is 1 centimeter. This is 1 centimeter, and the distance between here to here, that is also 1, and is being filled with electrolyte. Please try to draw better than me, huh? If you draw like this, you may not pass in the exam. I too don't have to appear any more exam. So for I can draw like this. Draw.
Done, sir.
See here. In this case, what has happened? We have put electrolyte and we have put 2 electrodes. What is the cross section of the electrode? 1 centimeter. And what is the distance between them? It is 1 centimeter. So this is the cell. Let me, if I only concentrated the electrode, okay? So don't draw. Say so this is the electrode. Okay. So this is 1 cm. This is also 1 cm. Distance between them This ones. Okay. Who is going to conduct the electricity? It is the ion which is present here. It is ion which is present. Okay. So this will go to this side, this will come to this. This will go to this side, this will come to this. This will go to this side, and okay. So it is this. They are the one which is going to conduct electricity. Cathode and anode. So let me write the definition again. Alex. Conductivity of an electrolyte is the conductance of all the ions present in 1 centimeter square, sorry, present in a solution, in present in a solution that is placed between two electrodes of cross section 1 centimeter square and placed at a distance of 1 centimeter. See, again I'm telling you, don't get confused. Say that you have organized one party in a hotel. You did not book the entire hotel. So the place where all your guests are there, their foods are being served and their waiters are there. So it is the waiter who is going to bring all the food items to you, and the what waiter from outside will not come. All the waiters are already being placed inside. So if all their movement, if their movement is slow, then the amount of electricity will be, food supply will be slow. And if they're fast, it will move fast. See here, we have plenty of solution outside also, but the electrodes are here. So it is the ion which is present in between these two electrodes are going to move toward respective electron and going to conduct electricity. So if I have taken out, assume that I only see these two electrons and nothing else, then does it not look like if I join it, does it not look like a small container where all the ions are present? Ion outside are not conducting electricity. It is only the ion which is conducting electricity here. Now, here what you find, what is the cross section, what is the volume of solution present here? That you know very well. Volume is equal to what? Cross section into distance. Cross section is what? 1 centimeter square. And what is the distance? 1 centimeter. So it is 1 centimeter. That is, we can say It is the amount of electric current or electricity conducted by all the ions present in 1 centimeter cube of the solution in between two electrodes. So this is I wanted to mean. Okay. Okay, you write this one, don't write this portion. Okay, you can draw up to this, then again I'll write down for you. I'm going very slow. Later on I'll speed up. With what? This is our model now. So you can write here or it is the amount of electricity conducted by all the ions present in 1 centimeter cube of the solution. And to make it very specific, electrolytic solution, where it is placed between two electrodes. Of cross section 1 centimeter square. Kept at a distance of 1 centimeter. Okay. Now see, we have put the condition 1 centimeter, 1 centimeter. So this is our fixed value. So this is called specific conductance. If the electrodes are not 1 centimeter and if the distance is large, we'll never call it, we'll call it conductivity, but we'll never call it specific conductance. Or it is also known as specific conductance. Remember, only when cross section is 1 centimeter square and distance is 1 centimeter, then only we call it specific conductance. Otherwise, we will call it simply called conductivity. If so many people are there, we call crowd. But if one person is there, we'll call by his name. That is the difference between conductivity and specific conductance. conductance, we did not mention the concentration of the solution. But when you make a solution, you cannot make it blindly. Na? It's not like making tea in your house. You can put 1 teaspoon, 2 teaspoon like this. Of course, for tea also have a concentration. If someone asks you how much sugar did you put, you will say one spoon, 2 spoon. That is also a unit of measurement. Okay. But when you make this electrolytic solution, we have to make a solution in a standard. Generally, what we do, we go for molar solution. So, in an electrolytic cell, if you put molar solution, then whatever the electric current they are going to conduct, that is known as called passive molar conductance. Okay, so let me write down. Please remember, for specific conductance or conductivity, the symbol is kappa. But for molar conductance, the symbol is not kappa, it is lambda m. Okay. I will write there molar conductance. Molar conductivity or molar conductance. Its symbol is lambda capital and m subscript. It is the amount of electricity conducted by all the ions present in one mole of an electrolyte. In a solution. It is denoted by lambda. In specific contact, don't write now anything. 1 molar solution is what? 1 mole of electrolyte present in 1 liter or 1000 ml of, so don't write solution. 1000 ml or what? 1000 centimeter. All right. Now, what is in case of the specific resistance? What did you find? In specific resistance, we find see here. This is the distance between two electrodes, and this is 1 centimeter square, sorry, 1 centimeter, and this is also 1 centimeter. So what is the volume? Volume is 1 centimeter. But how much it is there? 1000 centimeter cube. All right. Then how can find a relation between the specific conductance and molar conductance? This is specific conductance. Specific conductance is for 1 ml for 1 centimeter cube. Molar conductance is for 1000 centimeter cube. Okay. Now, if you want to find molar conductance, then what you have two options to do. One, you measure it for 1000 ml, you measure it 1000 times. Every time you measure 1 centimeter cube, throw and put the second, then third, fourth, then you go for 1000 experiment. This is one condition. Second condition, what I will do? I will keep the distance between them 1 centimeter cube. And I will try to stretch this electrode very long. Okay? Very long. So that 1000 ml can be accumulated. Okay? Just like that, if you go to market, if you go to buying socks, you will find with age the socks sizes are different. But these socks, if you wear, you wish you can pull up to your knee. Otherwise, you can leave it. Girls are wearing the stockings or something like that. They can stretch it and they can not only put their feet, they can put both the legs in two different portions. They can put, they can put their whole leg. Okay, that is, you can stretch it. Same thing is there. That is, it is the amount of electricity conducted by all the ions present in 1 molar solution placed between two electrodes at a distance of 1 centimeter. But one but is there. What do I do? That surface area of the electrode should be large enough to accommodate the entire solution. So this is also another definition of molar. If you wish, I can write down, but I'll be giving you a note from there. You can read. Okay, now dear, it is always not necessary that 1 molar solution should always contain 1000 ml. Say I have taken 36.5 gram of HCl in 1000 ml of solution. This is equal to 1 molar HCl. But I may not require 1000 ml. I may require 100 ml. Then why should I throw the 900 ml? So what I can do, if I take 3.65 gram of HCl in 100 ml, this is also 1 molar solution. All right. So this is also 1 molar solution. This is also 1 molar solution. So in that case, what did I tell you? That if you want to find molar conductivity or molar conductance for 1 liter, you have to measure it 1000 times. Why? Because you have 1000 ml. What is the volume? Volume is 1000 ml. So can I not write that delta M is equal to kappa? Why kappa? Because kappa stands for 1 ml. How many times I have done it? it depends upon the volume. So I can write lambda m is equal to kappa into V. Okay. So this is a relationship between molar conductivity or molar conductance with specific conductance. So I'll write now here. Relation between molar conductivity or molar conductance lambda m with specific conductance. What is this? So I'll write lambda m is equal to kappa into V. If it is 1000 ml, V stands for 1000. And if it is 500 ml, V stands for 500. If the molar solution contains 100 ml, V stands for 100. Okay? So, this is the one. Now see here. What is concentration? Concentration, suppose if I write C, it is nothing but the number of moles by volume. So moles is N and V stands for. All right, see here. Volume is inversely proportional to the concentration. So volume V is inversely proportional to concentration. C. Therefore, I can write that lambda m is equal to kappa divided by C. Okay. Acha. For 1 molar solution, what should I write? For 1 molar solution, n is equal to what? N is equal to 1. I'll write now here 1 mole. And V is equal to what? 1000 ml. All right. So I can put here concentration C. I can write it here as, therefore, lambda m is equal to kappa by n. Okay. Into, okay. This is for your numerical calculation. This is directly in your book they have written, but they did not explain. For molar now we are coming to an important portion. Variation of conductivity. Conductivity is what? Kappa. And molar conductivity, lambda m, with concentration. Okay, so let us try to understand from a very simple experiment. Say in this one, you have dissolved sodium chloride, common salt. Okay, you thought of sometime if the electrolytic imbalances are there, we take even salt solution also. But you have found it is too saline. Okay, so now to that, if I add more water, what will happen? See, it is filled till to the brim. What will happen if I more water? What will happen to the filled glass containing salt? If I pour more water, what will happen? Say,
It would be less saline.
huh? Yes, tell. Why should you feel shy? Tell and tell
It
it
would be
loudly.
less saline.
Balai. See, when you pour water, you are correct only. When you pour water, what will happen? Water will overflow or not? Water will overflow. And as the water overflows, the salt which is there, it also come along with the water. As the salt has overflown, has moved along with the overflown water, so the amount of salt inside is less. So in that case, what is going to happen? It will be less saline. That you know from our normal life. You find, suppose you are cooking at home, you are making dal and you have poured more salt there. Now the dal you cannot throw. What you do? We pour some more water. When the volume increases, then the concentration of the salt per unit volume or per ml decreases. That is, with dilution, concentration decreases. So same thing is going to happen. Say this is your electrolytic cell. Okay, and these are the electrodes. So this is the electrode. This is the electrode. Okay, and this is you placed in a chamber and where to this. Sorry, here the electrodes. You have pour more water. The water will overflow, and the number of ions inside within the two electrodes decreases. And when it decreases, the conductivity decreases. So the conductivity of a solution decreases with decrease in concentration. But it is very easy to say theoretically. But how to decrease? Can you pick? Can you see the ions? Can you pick it with a forceps? Well, I don't want this. I don't want this. I'll throw it. It's not possible. So in that case, what you have to do? You have to pour water right in the middle of the electrodes, by which the water will overflow, and by that way the number of the ions within the electrodes will decrease. That is, I can say the conductivity decreases with increase in dilution. Why? By that way, the number of ions present within the electrodes decreases. So you can write now. The conductivity or specific conductance kappa decreases with decrease in concentration of electrons. Or what we can say? Or increase in dilution. Why? It is because with increase in dilution, we'll write here. Example, pouring water. The number of ions present within the two electrodes decreases. The number of ions present within the two electrodes, and as a result, the amount of electricity conducted by ion, because ion is less, so the electricity conduction also will be less. Ions molar conductivity of an electrolyte of an electrolyte. See, in case of conductivity decrease, your molar conductivity increases. Increases with decrease in concentration or increase in, don't write, first you try to understand dilution. You know why? See, molar conductivity is a product of conductivity and weight. When you pour water, what happens? On dilution. See here, this conductivity decreases. But what happens? Total volume of the solution increases or not? This increases. Suppose you've taken 10 ml, you added 90 ml, total volume has become 100. It is going to decrease. Okay? So in that case, this is going to decrease, but it increases by many fold. So in that case, what is going to happen? The product is going to be more. So we'll write here molar conductivity is the product of conductivity kappa and volume V of the electrolytic solution. On dilution, conductivity decreases, but the volume of the solution increases by many fold. Manifold. Hence, their product, that is what? Kappa into V. Hence, their product increases. So, molar conductivity or molar conductance of a solution increases with decreasing concentration or by increasing